All right, geometry. So we are in chapter 2, lesson 8, the last lesson of this chapter. And our essential question today is, why is it important to think logically? That's kind of been the theme of our last few lessons. So we have two kind of vocab words here, or theorems, that we have to know, two rules, and they're pretty basic and we already know what they are. So the first one is the complement theorem. That has to do with complementary angles. So when we have two angles together that add up to 90 degrees, those angles are complementary. So we're going to say if the non-common sides of two adjacent angles sorry, you have to watch me write everything out. Two, I'm going to abbreviate. No, I won't. You need to see this. Adjacent angles. So here we have two adjacent angles. Non-common sides are the sides that they don't share. So they share this middle line right here, this side, but they do not share this side. That only applies to angle 2. And they don't share this side. That only applies to angle 1. So if these non-shared, these non-common sides, form a right angle or a 90-degree angle. Form a right 90-degree angle. Then the two angles are complementary. Am I going to spell that right? Yeah. So complementary angles add up to 90 degrees. And our example here would be, we could say the measure of angle 1 plus the measure of angle 2, they both add up to 90 degrees. So that's the complement theorem. The supplement theorem is basically the same thing, but for supplementary angles. So our two side by side to our adjacent angles make up a linear pair, and they add up to 180 degrees. In other words, they are supplementary. So if two adjacent angles form a linear pair, a linear pair is just two side by side angles that make a straight line. Then those angles are supplementary. And supplementary is 180 degrees. Oh, that was supposed to be an 8. Okay, so for example here, we could say that the measure of angle 1 plus the measure of angle 2 adds up to 180. Whatever this is plus whatever this is, together they add up to 180 degrees, which is a straight line. And it's 180 degrees because a full circle is 360 degrees, and a straight line is exactly halfway around a full circle. If we went all the way, it'd be 360. We went half the way, so that's 180. All right, so first example here, we have a little picture over to the side. Try and zoom in there so you can get a good look at it. These notes are also here in this folder for this lesson, 2-8, so you can always pull it up and look there. This is the picture we're looking at, and the question says, if the measure of angle 1 equals 23 and the measure of ABC equals 131, find the measure of angle 3. So if this guy's 23 degrees, this angle right here, this entire angle, ABC, is 131 degrees, what is the measure of just this little angle down here? Well, what's the one piece that it doesn't tell us in words, but that we can see from the picture? We can see that angle 2 is 90 degrees, right? So we know that all three of these angles add up to the whole thing, which is 131 degrees. So we have to add angle 1 plus angle 2 plus angle 3, and that's going to add up to 180 degrees. Now, I am a visual learner, so everything I do is like color-coded. I realize everyone's not like that, but I am, so that's how I'm going to do my notes here. The measure of angle 1 plus, I'm going to get all my colors situated. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. I'm sorry, equals 131, sorry, equals the entire angle, which is, I'll do it in purple, ABC. I'm getting ahead of myself, sorry. The measure of angle ABC. So angle 1 plus angle 2 plus angle 3 equals ABC. And it tells us that angle 1 is 23, right here. So I'm going to replace angle 1 with what it is, 23. The measure of angle 2 we saw from that picture is 90 degrees, right? The measure of angle 2, where that little red box is in the corner, that box tells us it's a right angle, which means it's 90 degrees. So I'm going to put 90 here. And then I don't know what the measure of angle 3 is. That's what I'm searching for. That's what I'm trying to figure out. But I do know that the measure of angle ABC, the whole thing, is 131 because it tells me that right there. So I'm going to write 131. So now I can just solve this. It's an algebraic problem. Zoom out a little bit. 23 and 90 is 113 plus whatever the measure of angle 3 is equals 131. I'm going to subtract 113 from both sides of my equal sign. I want to get rid of it here. So to make it 0, I subtract, and whatever I do on one side of the equal sign, I have to do to the other. So I will be left with the measure of angle 3 equals, and then 131 minus 113 is 18 degrees. All right, so that's our little math example. Here's another example. Now, here is a lovely, lovely proof. I know how much you guys are so excited about doing all these proofs. So here is a nice example of one. First of all, it tells us our given, do I have a highlighter? No, darn it, I was gonna highlight it. Our given measure of angle 1 is the same size as the measure of angle 3, and the measure of angle 2 is the same size as the measure of angle 4. So I've got angle 1 and 3. They're the same size, and 2 and 4 are the same size, which basically tells me this entire thing is going to be the same size as this entire thing, right? So we have to prove that. We have to prove that the measure of angle ABC, this entire guy here, is congruent to this entire guy. Their measures are equal, right? So they wrote the proof out for us, and we have to fill in the rules that they use to get from one step to the other. All right, so we always know in a proof that the first line is our given, and we can see that it matches. This information matches this here. So our reason for writing it first is because it's the given. Second, now it tells us that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 2. I don't know why they wrote that yet. I mean, I'm not saying that they did it wrong. They did it correct. I'm just saying I'm not sure why that was the step that they chose to do, but just looking at it face value, this is the reflexive property of equality, right? When one side of our equal sign matches the other side exactly, like A equals A or 10 equals 10, this is the same thing. Angle 1 plus angle 2 equals angle 1 plus angle 2. They look the same. So my rule that I'm using here is the reflexive property of equality. And I'm going to abbreviate it there. Reflexive prop of equality. All right, so then going from line 2 to line 3, what did I do? Looks like the first part stayed the same, 1 plus 2 equals, but then here it changed. So what rule tells me that I can change angle 1 to angle 3 and angle 2 to angle 4? And this is where it gets a little like, wait, what? Where we're trying to figure out where they're coming from, right? Well, right up here, it tells me in line 1 that the measure of angle 1 is equal to the measure of angle 3. So it looks like all I did here was replace angle 1 with what it was equal to, right? Kind of the same thing as 2 and 4. It tells me in the given that angle 2 and angle 4 are equal, right? So all I did from line 2 to line 3 was replace angle 1 with angle 3 because I just substituted, they were equal, and I replaced angle 2 with angle 4. Again, I just substituted because they're equal. So for my reason here, why did I go from step 2 to step 3? Just substitution, that's all I did. I'm not even going to write property of equality because it's just substitution. There's only one substitution property. Okay, so then I go from, now I'm here. Now I know angle 1 plus 2 is equal to angle 3 plus 4. Angle 1 plus 2 is the same size as angle 3 plus 4. Okay, so I'm here. What did I do next? Step 4 says the measure of angle 1 plus the measure of angle 2 is equal to the whole thing, ABC. And the measure of angle 3 plus the measure of angle 4 is equal to the whole thing, DEF, right? So whenever I add up two smaller parts to total one bigger part, just like the segment addition postulate, two smaller segments add up to one big segment, this is kind of the same thing. We're going to say this is the angle addition postulate. When two smaller angles add up to one big angle. If this was 30 and this was 60, 30 plus 60 equals 90, right? So 30 plus 60 equals 90. That's just the angle addition postulate. Two smaller angles add up to their one big angle. Okay, and that goes for both of these steps here. So I just lumped them together in one easy step, and the reason for both of those was angle addition postulate. So then I go from line 4 to line 5, right? So the measure of angle ABC is equal to the measure of angle DEF. So how do I know that? What rule tells me that I can go from line 4 to line 5, right? Well, if I start looking up here, to get from step 3 to step 4, we used angle addition postulate. Now we're going to combine steps 3 and 4 to get to step 5, right? So in step 3, it told me that this whole thing equals this whole thing, right? 1 and 2 is equal to 1 plus 2 is equal to 3 plus 4. Then in line 4, it told me that 1 plus 2 is the same thing as ABC. So from 4 to 5, all I did was I started in step 3. I took 1 plus 2, measure of angle 1 plus the measure of angle 2. I replaced it with what it's equal to that it told me in step 4. The measure of angle ABC is the same thing as this. So instead of writing all of this, I'm going to replace it with just the measure of angle ABC. Same thing with the other side of the equal sign. In step 3, I have measure of angle 3 plus the measure of angle 4. In step 4, I said that that was equal to the measure of angle DEF. So in step 5, I'm going to put those together, and I'm going to say angle 3 plus angle 4. I'm going to replace it with DEF and just write this guy right here. So step 3 and step 5 say the same thing. Angles 1 plus 2, which is ABC, equals angles 3 plus 4, which is DEF. How do I know ABC is the same as this? Step 4. 1 plus 2 equals ABC. How do I know DEF is the same as this? Step 4. 3 plus 4 equals DEF. So I went from 3 to 5 using step 4 in the middle. And since all I did was substitute one big angle in place of the two angles that add up to it, this step is substitution. So that was our progression. I don't want to break it down too much because it'll get confusing, but you'll just see the more properties that we do. It starts off with the given, then usually they'll tell us a couple random things that we're like, why are they telling us that? And we'll list out which properties they are. And then we'll see down at the bottom that they start combining steps, just like we did here. We had step 3, we had step 4, then we put them both together and created step 5, which was substitution. All right, example 4. It says angle 6 plus angle 7 form a linear pair. What does that mean? That they are supplementary, right? They add up to 180 degrees. If the measure of angle 6 is this and the measure of angle 7 is this, find x, the measure of angle 6, and the measure of angle 7, and state the postulate or theorem used, right? So first thing we're going to do is highlight this guy, and then I'm going to highlight this guy. I'm trying to do it in different colors. I don't know if you could tell that. Okay, and I've got to solve for x, 6, and 7. Okay, so first thing I'm going to do is just say that the measure of angle 6 plus the measure of angle 7 adds up to 180 degrees because they make up a linear pair. Okay, so once I say that, Then I can just substitute. I'm going to leave that the same, but I'm going to replace the measure of angle 6 with what it's equal to, 3x plus 32. And then I'm going to add that to the measure of angle 7, which it says is 5x plus 12. So now I've got my equation. Now I can solve for x, right? A little bit of mental math. We'll do some combining in our head here. 3x and 5x is 8x. Plus 32 plus 12 is 44. And that's still equal to 180. And then I've got to subtract 44 from both sides of my equal sign to start getting rid of these numbers around x. So I subtract 44 and I'm left with 8x equals 180 minus 44 is 136. So once we divide both sides of our equal sign by 8, right, to get x by itself, we're gonna end up with x equals 17. Okay, so there's the first thing we had to solve for, right? We had to solve for x equals 17, we got it. So now that I know that x equals 17, I can plug that back into the measure of angle 6 and the measure of angle 7 to solve for the actual measure of each of those, right? So for the measure of angle 6, I know it's 3x plus 32, and now I know that x is 17, so 3 times 17 plus 32. And 3 times 17 plus 32 equals 83 degrees. It equals 83, and then I know because we're talking about an angle measure, it's 83 degrees. Okay, and then the measure of angle 7, now you can actually do this two different ways. We know that angles 6 and 7 add up to 180. So you could either plug 17 in for x and solve, or you know that angle 6 is 83, so 83 plus what equals 180? You can just subtract 83 from 180, and that'll give you the measure of angle 7. Either way will work. Okay, so we're going to do 5 times 17 plus 12, which is going to be equal to 97 degrees. So if we added up 97 plus 83, they would equal 180. So what was the theorem used here? The main one that we used? We used the supplemental theorem, the supplement theorem, that one that we learned up at the top of the notes. So we're going to say supplement theorem. Nothing in this problem told us to set these two angles equal to 180. Right? Oh, sorry, I didn't realize you couldn't see that. Sorry. Nothing in these angles, nothing in this problem told us to set these equal to 180. We had to know the supplement theorem to know that if they made a linear pair, that means they are supplementary and they add up to 180 degrees. So we used that to use algebra to solve for x. Once we found x, we plugged it back in. Okay, and then last example on the front of the notes here. Sorry, the notes are kind of long today. All right, if angle 1 and angle 2 are vertical angles, that's the bow tie. Vertical angles are across from each other, share a vertex. And the measure of angle 1 is blah, 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 and the measure of angle 2 is blah, blah, blah. Find the measures of angles 1 and 2. So what do we have to know here to use all this information? First thing it tells me is measure of angle 1 is this guy. Actually, that's not the first thing it tells me. First thing it tells me is that they are vertical angles. Measure of angle 2 is this guy, and they tell me that they are vertical. So what do I know about vertical angles? I know they are the exact same size. They are congruent. So I know vertical angles are congruent, or they are equal in size. So first thing I'm going to do here is set equal to each other the measures of angle, the measure of angle 1, and that's equal to the measure of angle 2. And then I'm going to substitute, right? I'm going to bring down my equal sign. Measure of angle 1 is d minus 32. That was like a crappy looking d. And then the measure of angle 2 is 175 minus 2d. and then I can start solving for D with my algebra. So here I've got D's on both sides. I always want to get rid of the smallest variable, the smallest D. So I'm gonna add 2D to cancel this out. Negative 2D is smaller than 1D. So I'm gonna add 2D here and that goes away. I'm gonna add 2D here and I get 3D minus 32 equals 175. And in the same step, I'm gonna go ahead and get rid of this minus 32. I'm gonna add it to both sides. So 175 plus 32 equals 207. Once I know that this is true, then I know I need to just divide both sides of my equal sign by 3. And once I do that, I get D equals 69. Please make sure on your assignments when you hand in work, if there's a problem like this, like I'm a teacher and I'm writing out all these steps, you know, like that's a lot. You're not just going to do it in your head. Even if you're smart, like not smart, everybody's smart. Even if you're super quick with math and able to do it in your head, I still want to see what steps you're using. I want you to get used to seeing what steps you're using laid out in front of you. So you have to show me all your work, all your steps like this to get credit for your assignments. Please do not just have a problem like this and just put D equals 69, because that kind of just shows me that you probably copied the answer from somewhere. If you actually went to the trouble of doing all this work, you're sure going to make sure you show me all that work that you did, right? You're not going to write it on a separate piece of paper and throw it away. I want to see all of it. All right, so make sure you're showing your work. And then, so now I have to solve for the measures of angles 1 and 2, now that I know what D is. So the measure of angle 1 again was D minus 32. D we know is 69, and 69 minus 32 is 37. And we know it's the measure of an angle, so I'm going to put 37 degrees. Then measure of angle 2, do that in red. And that is 175 minus 2D. 175 minus 2 times, and then D is 69 again. So once we do 2 times 69, which is 138. 175 minus 138 is 37 degrees. And we also know that these are vertical angles. That was our whole thing. We had to set them equal to each other. So once we plug our variable back into both angles, they should be the same, right? They're vertical angles. So they should be the same. And does this one ask us? It does not ask us what we used here. There is a vertical angle theorem that just says if angles are vertical, they're the same size, but it doesn't ask us to write that. So we're not going to worry about it yet. These vertical angles, same size. All right. Go back and rewatch that. If I went too fast, ask me questions if you have questions. Okay, so we've got a little bit more stuff. We're halfway through the notes. Thank you for following along. Next part, jump start. This is just kind of a little practice. Usually we do it as bell work when you're in class, but we'll just do this together real quick. All right, what does it mean for two angles to be complementary? And what does it mean for two angles to be supplementary? I'm not gonna write out sentences. I'm just gonna point and say complementary angles add up to 90. And supplementary angles add up to 180. Complementary angles make a 90-degree right angle. Supplementary angles make a straight line. Okay, example 3. We've got another lovely, lovely proof here. I know you guys love them. All right, we've got two pictures. It looks just like the one we did on the front, right? Prove that if the measure of angle ABC is equal to the measure of angle DEF, and angle 1 and angle 3 are equal, then we have to prove that the measures of angles 2 and 4 are equal. So it's saying if this whole thing is the same size as this whole thing, ABC is the same as DEF, and this top part, angle 1, is the same size as this top part, angle 3, then we have to prove that this bottom small angle, angle 2, is also the same size as angle 4. And we can just see it, and we can kind of say in our heads, well, duh, they're equal, because it's all equal. But we have to actually formally go through the steps and use the correct rules to work logically through the process of getting from the given to that last statement in our proof. Okay, so line 1 is always the given. I'm just going to copy that down. the measure of angle ABC is equal to the measure of angle DEF. And then the second thing they told us is the measure of angle 1 is equal to the measure of angle 3. Okay, and the reason I wrote that down is because that's what was given to me. That was my starting point. All right, line 2. What am I doing next? Okay, if I kind of follow along to that proof that we did on the front, what was the next thing they used here? This is what we did on the front. Okay, so we set our given statement. And then, actually, I don't want to follow the same. I want to follow the same thought logic. I am going to use the angle addition postulate, right? What am I trying to show here? If I know this guy is the same as this guy, and I know 1 and 3 are the same, I have to prove 2 and 4 are the same. Well, first of all, I need to show that 1 and 2 add up to this whole thing, and 3 and 4 add up to this whole thing. And then based off of that, I can work forward. So I'm going to say in line 2 that measure of angle 1 plus the measure of angle 2 adds up to this entire ABC. And also, same thing for the second angle there, angle 3 plus angle 4 adds up to, like a hair on there, measure of angle DEF. And since all I did here in step 2 was add 2 smaller angles to equal the bigger angle, just have 2 examples of it, that's the angle addition postulate, just like we showed on that front proof. And I'm abbreviating. Don't just put angle, or don't just put angle add, or don't just put add. You have to use the entire name of the rule, the angle addition postulate, but you can abbreviate each word in that rule. Okay, next line. So now we've said that these 2 add up to the whole thing, these 2 add up to the whole thing. Where do I go from there? In line 3, I'm gonna say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Why did I say that? Well, look at my steps that I have so far. I mean, I'm not making up stuff, right? I have to work off what's given to me. So I'm basically combining step 1 and step 2. The top line in step 1 says that ABC is equal to DEF. And then in step 2, I said what ABC is also equal to and what DEF is also equal to. So I'm just replacing ABC with what ABC is equal to, and I'm replacing DEF with what DEF is equal to in step 3. So all that was substitution. I just replaced a value with what it's equal to. I combined steps 1 and 2 and got step 3. Now I still haven't used the bottom part of step 1. I haven't used angle 1 equals angle 3 yet, but guess what? I'm about to, because there's a reason why they gave it to me, so now I got to use it. I know the bottom line in any proof always has to match my proved statement, so I can even go ahead and write that down. I know in step 5 here, I'm going to have to say that angle 2 is equal to the measure of angle 4. I don't know the reason yet because I don't know what the step in front of it is. But remember, the bottom statement always has to match my proof. And this is the last line it gives me, so I know it's the last statement. Okay, so how do I get from step 3 to step 5? Well, here I have 1 plus 2, and here I just have 2. Here I have 3 plus 4, and here I just have 4. So it looks like I got rid of measure of angle 1 here, and I got rid of the measure of angle 3 here. So does it tell me anywhere that I can just subtract those things from either side of an equal sign and the sides will stay equal? Yes, it tells me that up here in this line, right? It says that they are equal to each other. So in this middle step, I'm actually just going to, and it doesn't matter which one I do, but I'm actually going to rewrite. I'm either going to write measure of angle 1 as angle 3. I'm going to replace it, substitute. Or I can replace the measure of angle 3 with the measure of angle 1. It doesn't matter which one I replace. I just want these to look the same. So either they're both going to say angle 1 or they're both going to say angle 3. But either way, they're equal to each other, so it doesn't matter what either one says. So I'm going to put the measure of angle 1 plus the measure of angle 2 is equal to, and then I'm going to replace this with the measure of angle 1 and then leave the rest of it the same. Right? So this step told me I could replace that. And once I replace something with what it's equal to, that's substitution. What rule told me that I could go from step 2 to step 3, or any of these previous steps to step 3? The rule of to step 4, the rule of substitution. I can go from line 3 to line 4 when all I did was replace angle 3 with angle 1, because it tells me up at the top that angle 3 and angle 1 are equal to each other. That's substitution. So then going from 4 to 5, now I can see that all I did on both sides of my equal sign was subtract the measure of angle 1. I just got rid of it. And whenever I get rid of or subtract the same thing from both sides of an equal sign in math, that's the substitution property, the subtraction property of equality. When I subtract the same thing from both sides of an equal sign, that keeps the two sides equal. I get rid of it here, so I have to do the same thing here. So even though both sides were worth more and now they're worth less, they're still equal to each other. That was my goal. Okay, so I made it from the given statement to the proved statement with these steps in between using these rules. And I promise you are not expected to know how to write this on your own yet. Okay, the more and more we do of these, the more you'll see like, oh, every single time it seems like we're combining steps 1 and 2 to get step 3. Okay, all right. Over time, you will get used to seeing these. Okay, they're not super fun, but you will get used to them. You are not expected to know how to do all of this on your own yet. All right, next part, almost done. Theorem, properties of angle congruence. Use the angles to show examples of each property, okay? So first we're looking at reflexive property of congruence. So what can we say here? I have 3 things here. I have 3 angles here. Reflexive property of congruence. Let's say this is angle 1 right here. The reflexive property says the measure of angle 1 equals the measure of angle 1. So the reflexive property of congruence would say that just angle 1, whatever the measure is, it doesn't matter, is congruent to angle 1. Reflexive property of equality says that the measures of each angle equal themselves, right? One side looks exactly like the other side, but we're talking about numbers. So whatever this is, let's say it's 30 degrees, 30 equals 30. The reflexive property of congruence, still both sides have to match, but now instead of talking about numbers, now we're just talking about a physical thing, right? There is a physical angle 1. We don't know what size it is, we just know there's an angle 1. And it's gonna be the same size as itself. So angle 1 is congruent to angle 1. That's the reflexive property of congruence. One has to deal with size, one has to deal with the physical thing itself, not size, just the idea of it. Symmetric property of congruence. All right, so I've got angle 3 here, and we'll do angle 2 in green. All right, so the symmetric property of congruence basically says that I can flip-flop 2 sides of an equal sign. So if I said angle 1 is congruent to, I should have done that in black, right over it. Angle 1 is congruent to angle 2. Then the symmetric property of congruence says that I can just flip-flop those and they're still congruent, right? I can say angle 2 is congruent to angle 1. And it doesn't change anything. These 2 statements say the same thing. So symmetric property of equality says that I can flip-flop 2 sides of an equal sign. Symmetric property of congruence is the same thing, just with a congruency sign. I can flip-flop 2 sides of a congruency symbol, and it doesn't change anything. Okay, and then third, the transitive property of congruence. Okay, remember the transitive property is when we cut out the middleman, right? Like just to review, if I said A equals B and B equals C, so we can just cut out the middleman and say that A equals C. Just start with the front and the back and just get rid of this guy in the middle. It doesn't really matter, right? That's what we're doing with congruence now, talking about the measures of angles. So if I said, can you see? Yeah. Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. And I did angle 3 in blue, okay? So that was a terrible congruency symbol. I hope yours are better than mine. Then I can cut out the middleman. I can cut out angle 2 and just say that angle 1 is congruent to angle 3. Everybody good with that? Just like you with your friends, like if you said you're 15 and your friend Bob is 15. I know y'all don't have friends named Bob, but you're 15, your friend Bob is 15, and your friend Bob is the same age as your friend Chris, who is also 15. You can just cut Bob out of the whole deal and say that you're the same age as Chris. You're both 15, right? We're just cutting out the middleman, but we're doing it with congruency symbols. Hopefully that makes sense and I didn't confuse it. Okay, last little bit. Check your understanding. Write a 2-column proof. And we're going to do this together because I told you I'm not expecting you to know how to do this first. Okay, so given that angle 4 is congruent to angle 7, here's angle 4, here's angle 7. I marked them congruent. We have to prove that angle 5 is congruent to angle 6. So we're trying to prove that this guy is congruent to this guy, right? That's our goal. So first of all, I want to start off with the given statement. Angle 4, not 1, is congruent to angle 7, and that's given. Easiest step in a proof, right? Okay, then step 2, what's the next thing I need to know? Well, I know that 4 and 5 are vertical angles, so I'm going to say that. Angle 4 is congruent to angle 5, and how do I know that they're congruent? Because they're vertical, right? Vertical angles are formed by 2 straight lines that cross. So 4 and 5 are vertical, therefore they're congruent. This is vertical. For right now, you guys can just write vertical angles. The reason that we know they're congruent is because they're vertical angles. There's actually a theorem, like I said, called the vertical angles theorem. But we haven't really gone over that per se yet. That's all the vertical angles theorem is, though. If 2 angles are congruent to, if 2 angles are vertical to each other, that means they are congruent. Okay, what's the next thing I can say? Well, I'm trying to, remember, get to 5 and 6 being congruent. I know 4 and 7 are congruent, and I've just said that 4 and 5 are congruent as well. So it seems like I need to say this relationship now, right? So I'm going to say that angle 7 and angle 6 are congruent. Also because they are vertical angles. So same reason, vertical angles or vertical angle theorem. Either one will work. Why can't I write? Do you have days where you like can't write? And if any of y'all said, Miss Norm, that's every day for you. Got you. I hear you. Just kidding. All right, and then for the last step, remember we're going to combine previous steps, right? So I said 4 was congruent to 7, and I also said 4 was congruent to 5. And then I said 7, 4 and 7 are congruent, and 7's congruent to 6. So in my last statement, it has to match my proof, which is that angles 5 and 6 are congruent. Angle 5 is congruent to angle 6. So what did I use here to say that, right? I used substitution. Oh, yeah. Okay, we need both of these steps. Sorry, I thought there was one big step going from one. Ignore me. Ignore the long, awkward silence. Okay, so 4 is the same size as 7. 4 is the same size as 5. 4 and 5 are the same. So up here where I said 4 is congruent to 7, I could then say 5 is congruent to 7, right? And then I said that 7 is congruent to 6. So if I said 5 is congruent to 7, and then I replaced 7 with 6, I could say 5 is congruent to 6. However you look at it, to get to this last step, I use all of this up here and I use substitution, right? I substituted 5 in place of 4 and I substituted 7 in place of 6. And I just rewrote this top statement here. Good, makes sense? I hope so. All right, solve for x and the measure of angle QWT. We're done with proofs. Now this is the last little math portion. Here's our angle we're looking at. Okay, so again, I was saying we have to solve for x. and the measure of angle QWT. So it doesn't give me anything, but it shows me this picture. So QWT, I've got to solve for that. What's the only thing I know here for a fact? Do I know that these two angles are congruent? No, they're probably not. They don't look congruent, but I don't know. What do I know for a fact? I know that this whole angle, this bad boy right here, is 90 degrees because this little red box in the corner tells me it's 90. So I know for a fact that these two angles, this guy and this guy, add up to 90 degrees. So the first thing I'm going to do is add them together and set that equal to 90 degrees. So I'm going to say, not far enough over, okay, 2x plus x plus 6 equals 90. And then I can solve for x. 2x plus x is 3x plus 6. I'm going to subtract 6 from both sides of my equal sign. 90 minus 6 is 84. And then I can divide both sides of my equal sign by 3, and 84 divided by 3 is 28. All right, so it says to solve for x and the measure of QWT. So this whole angle. Now that I know x is 28, I know the measure of QWT is 2x. And now I know x is 28, so 2 times 28 equals 56 degrees. That's the measure of QWT. Makes sense? Easy peasy lemon squeezy. Let me know if you guys have questions on your assignment for any reason. Thank you.